Hello everybody, or whoever is watching this. Today I'm going to be answering the last question on the midterm exam by kind of looking at some of the code that we've discussed in class or things that I've programmed on the side on my own. So without further ado, let's jump right into it. The first question is, what is the difference between local and global variables? And to answer this question, we kind of first have to define what a function is. So essentially, a function is any body of code that is named and encapsulates other code. So with that in mind, what exactly is the difference between a local and global variable? And the answer pretty much boils down to one word, which is scope. And what do I mean when I say variable scope? That basically means what functions or what code in the program has access to the given variable. And so the scope on a local variable is contained within a function. So basically that means if we declare a variable like we do here inside of this function, which is our int main, it is only accessible within the int main. None of the outside functions like this void input has access to this variable directly, unless I would happen to pass it by reference. Now, a global variable, in contrast, is a variable that's defined outside of other functions, usually at the header of the program. And by doing this, now these variables up here are accessible by every single function in this program. So this void input, void calculations, void output, and the int main all have access to these up here. So for this program right here, which I coded for the midterm, I can't remember which question this was, but basically I set these constants up in the header so that every function had access to these constants. And that kind of segues into our the next part of the question, which is the three parts of a function. So technically there are three parts, but sometimes there can be two depending on how you write your code. But for the answer to this question, there are three parts. The first part is the function prototype. So whenever you write a function aside from the int main up in the header, you have to kind of initialize the function. So it's pretty much writing the first line of the function definition. And basically, you're declaring what type of function it is. So this is a void, meaning it's not going to return any value. You give it the name, and then you include all the variables that are going to be passed into that specific function. And this, like I said, this kind of initializes the given function. And so the next part is our we'll go down to the function definitions. So then once you've done that, then you go down and you write your actual functions and put the code within the function to perform whatever operation that you want it to perform. And that, like I said, that's the function definition. And then the last part of the function is the function call, because I mean you can declare these all you want, but if you don't reference them in your code, they're kind of useless. So once you're in your main function up here and you want to call one of the functions, you just type the name of the function and what variables you want to pass into the function, and then it'll once this line of code executes, it'll jump down to whatever function you've called. So like in this program, we've defined, we're converting pounds and ounces to kilograms and grams. So the first thing that executes is this input function. So it's going to jump down to the input function and passing these pounds and ounces by reference. And it's going to ask the user for their input, and it's going to send these variables back to the input value. And it's by reference, so it's manipulating these directly. Then our calculations function will execute, and we're going to pass these variables in. It'll jump down to our calculations, perform the calculations we want, and then return these the grams and kilograms by reference, jump back up in the code, and then it's going to go to our output function and jump back down to this output function down here, display the output, and then it's going to return 0. Next we have we were talking about arrays earlier in the semester and some common algorithms that you might use to solve different problems. And one problem that comes up a lot when you're using arrays is, okay, so once you've defined your array, great, you have your values stored in the array, but what happens if you want to take a value out of the array? And it's kind of hard to conceptualize, but if you do it correctly, it's a pretty neat trick. So basically, what you're gonna do is you're gonna declare your array, um, and I have my constant size. I've set it to 11 just to make it a little bit simpler. We have our array definition here. We pass our size in for the size of the array, and then I've just initialized these numbers just for the sake of simplicity. Then I have my delete value. This is just going to be the user entering their whatever index they want to delete from this from the list of numbers. And then what I'm going to do is I'm going to display the array on the screen so that the user can see what they what numbers they can pick from to delete. And then I'm going to ask them which number they want to delete, read in the value, and then this is where we get into the array algorithm. So basically, it's going to read in this delete value, so whatever index they decide they want to delete. And then it's going to jump into this code right here. And we're going to start our counter variable at whatever index they said. So if they said index 3, our counter variable is going to start at index 3 right here. And then once it starts at that point, it's going to set that index equal to the index after it. So if we had index 3 equals 4, it's going to look at the index 4 and assign that value back to the index 3. And it's going to do that for every single index in the array. It's going to look at the next index and assign it to the current index. And that's what it's doing here. And it's going to run this loop right here until the size, it's less than the size minus 1 because we're taking out a value. And then once we've executed that loop and it's terminated, then we're going to take the size and we're going to subtract 1. And then we're going to display the new array. So I'll kind of show you what this looks like. So we have our list of numbers right here, and our indexes range from 0 to 10. And I've put this 999 in there, just it gives us a value to delete, say we made a mistake or something. So that's going to be the 5th index. So it's asking me which index I want to delete, and I want to delete number 5. And now it's going to display my new array, and it's going to get rid of that 999. And I can do this with all of the other numbers. So if I want to run, let's say I want to get rid of the 4, and I type in the 4th index, now it's going to kick that 4 out and spit out my new array. And now finally we have our last part of the 4th question, which is talking about nested for loops. And when you're talking about nested for loops, especially when you're talking about dual nested for loops, you need to take into consideration that your overarching for loop is going to control the row, and then the loop nested within inside of that is going to be controlling the column. So the program that we're looking at right here is one of the labs we did earlier in the semester where we prompt the user for the number of stars they want within a diamond. So they enter the number of stars in the side, and then we have to take that information and print out a diamond on the screen. And the way that I've done this program is I have my one overarching row for loop, and then within each row, I have 3 other for loops that are controlling the different columns within that row. So if we look at the code here, we're going to enter the first row, and it's going to execute while the row is less than or equal to the length. And this right here is calculating the number of stars and spaces that are needed within each column. And once that information is determined, then I go to my first column loop, and it's going to display the spaces, and then it's going to display the number of stars, and then the last column for loop is going to display the number of spaces on the other side. And once all of these execute, once all the columns are finished, it's going to move to the next row and do this all again. So it's going to go row by row by row until it reaches it reaches the middle point of the diamond, where the entire diamond row is just full of stars. And then once that's finished, then I flip the previous logic and do it in reverse. So then we have our new row counter here. This is a totally different nested for loop. So this will control my row. And then once again, I have 3 different for loops nested within inside of this, and each of them controlling the number of blank spaces to the left, the number of blank spaces to the right, and then the number of stars in between. So then the first one will execute. It'll execute the number of spaces. The second one will display the number of stars, and then the last one will display the number of spaces on the right side of the diamond. And it'll run through this until it gets to the very end of the length, depending on what they enter for the number of sides. So when we take a look at this program, it's going to prompt us for our input, and we'll type in, we'll just say 10, and basically there's going to be 10 stars on every side. And like I was saying, the program is split in half right here. So this is the middle point of the code. And then once it gets here, then that's when the code logic flips in half. And then once again, we're printing out blank spaces on both sides and then the stars in between. And that's basically how you would do this program with nested for loops. If I can get my browser to shut.